Hey everybody, I'm here with Kristof, the designer of some pretty cool HDMI stuff up on GitHub. How you doing?
Yeah, I'm fine. Thank you.
So I've been following your work for over a year now, and I'm really glad I get to talk to you because I have a whole bunch of questions. But for maybe people that listen to the podcast but don't quite remember, would you mind giving just a short introduction and tell some of the projects that you've been working on?
Okay, I'm currently working on the DC HDMI project. It's a full digital-to-digital solution for video and audio on the Dreamcast with zero lag. and yes, I'm really kind of new to the retro scene. I started 2 years ago, and this is my first project.
Very cool. I'm not sure if you could hear the sirens in the background, but I live in the middle of Manhattan, so if I go, I might mute between talking, just so you and everybody listening doesn't get deafened by the sirens.
Okay.
Sorry. I mean, how did you? I have so many questions. I guess just where to start. Do you do digital video for a living? I mean, how does one just get into playing with Dreamcast signals?
No, I'm a software developer since 20 years now, and I started getting interested in FPGA stuff, and this is basically the starting point for the project. I get into retro gaming early 2016 and did some basic modding, RGB modding, the SNES and stuff like this. And then I read about the HDMI project, which Ozone, I think is his name, or Electron Ash,
Ash
is doing, and that. There was pretty much no progress since 2015, and and I get interested in this FPGA stuff, and I bought myself some development kit, and this was how it started. I soldered some wires onto the video DAC, and started playing around with this thing.
So you basically bought a developer's kit and then started teaching yourself Verilog and the FPGA programming setup?
Yes, this is exactly right. I found documentation online. I think it's called the Dreamcast Hardware Specification Outline. There and some schematics of the Dreamcast. And yes, I hooked up some wires, started learning to get along with Quartus Prime, the software for the Altera, now Intel chips, FPGA chips, and yes, it has a very powerful logic analyzer type thing built in, where you can see all your signals. And yes, this is how it started. Then I first implemented DVI video, not HDMI, and yes, this worked pretty well. It's about exactly 2 years ago I had the first working prototype, and then I started getting into HDMI stuff. The documentation is normally not freely available, but if you dig long enough in the internet, you find the documentation. And I did the first prototype has the implementation was completely done inside the FPGA, the whole HDMI thing.
Oh wow.
Yes.
Do you know what FPGA kit you purchased? Do you remember which one?
Yes, it's the DE0 Nano kit, I think. But if you want to start now, I would recommend the DE10 Nano, as it has the HDMI transmitter on board, so you can
Yeah, that's definitely where I was getting at with that. Is a lot of people want to start working into FPGA, but wouldn't really know a first step. So if you have you just recommended that one, that's the one to use.
Yes, this is the kit I
The
recommend
10
now. The 10 Nano. It's about I think.
I'm gonna write that down.
Sorry. Okay. I think it's about $130.
Oh, well, that's actually pretty reasonable.
Yes, and it has a very powerful Cyclone 5 FPGA. The part alone, bought in small quantities, is worth more than the whole kit. I think it's aimed at the educational market.
When I just spoke to Kevtris, he used the analogy, I hope I'm remembering it right, but when you program FPGA, it's more like writing out a schematic rather than programming a language. As a software programmer, do you have any insight into that and any comparisons?
Yes, it was a little bit hard at the beginning because I thought in a normal programming language, but it's more describing a circuit, and I have to. It took me a while to fully get into it and understand the differences, especially because Verilog looks very much like C, but it isn't.
See, that for me, like when this is a stupid example, but when I first started trying to learn Linux, I knew DOS so well because I was born in '81. My first computer was you didn't even have a hard drive. Every time you booted it, you had to run DOS commands. And I think it would have been easier for me to learn Linux if I had never learned DOS because I kept making the comparisons that didn't exist. So, yeah. You said that you started with a DVI kit and moved to HDMI. Your average user would think that both of those things are pretty much the same, but from somebody who's designing these things, how does HDMI differ from DVI?
It's basically it is DVI, but it has additional informations in the blanking area. There are data islands where additional data is transmitted, such as the audio. Information about the resolution, the video format, and so on. This is it's basically put on top of the DVI video.
And I'm assuming that anybody programming for HDMI doesn't have to worry about HDCP at all, especially for games, because it's not protected content.
Yeah, if you do the implementation yourself, you do not implement HDCP at all.
Because I know some of these protocols you're required to at least set flags, and that's probably a terrible analogy, by the way, but you have to at least, when you're creating things, acknowledge that it's there and set it to on and off. But with HDCP, and I've never done any kind of programming like that, so you just wouldn't even have to add it at all, right?
No. The HDMI transmitter we are using at the moment supports HDCP, but we do not touch it at all.
Good. So, I guess can you talk a little bit about the Dreamcast project itself? So, did you have to basically reverse engineer the video chip? Is it all the chips of the Dreamcast?
No, it's basically the video DAC. The lines coming from the GPU to the video DAC, and it's documented in the Dreamcast hardware specification outline. There's a description, a very very coarse description, how the video works. It's double clock, and it's transmitting basically red and the first half of green, and then the second half of green and blue in 2 clock cycles with 45 megahertz. So the actual video clock is 27 megahertz.
Do you see, is that a common thing in video that green is split between 2 clock cycles?
I don't know. I don't think.
Yeah, it seems odd to me. But so now this device, does this remove the DAC that's on there, or does this install on top of it?
On top of it, it's basically taking the video signals from the GPU to the DAC, and yes, but leaves everything installed. So analog video continues to work fine.
That's excellent. There's a lot of people that rely on this for things like that for streaming, and it's a pretty big deal because especially people that go on the road and do any live events, having to carry all of these splitters and cables and hope that everything still works. I mean, anybody that's ever been in a band knows the fear of pray that all of your equipment works when you get there and nothing's bad. So having just the Dreamcast with 2 outputs, it solves a lot of problems for a lot of people. Yes. So.
And the audio is there's the audio deck on board, and there you can get I2S audio.
So that's a full digital to digital audio as well, not an analog to digital conversion?
Yes.
That's really cool.
Yes.
Excuse me, it's very hot here. I need to keep hydrated.
Here too.
Oh, really? What is it now?
I think in Fahrenheit it's about 95.
Okay. It's hotter than here then. I think we're in late 80s. Where exactly do you live? Which cities?
In Cologne.
Oh, okay. Germany is one of the places that I have not made it to yet, but I really hope to get to soon, maybe this year even. So.
Oh, fine.
So when you're approaching the Dreamcast chips, was there any weirdness that you had to deal with for the DTV versus just VISA standards for the output? Because I know that's something that kind of drove everybody crazy for a while because it never really landed properly.
Yes, it's the Dreamcast basically puts out 480p, which is 720 by 480 pixels, visible pixels, but only uses the 640 horizontal pixels. And the problem with that is that the sync is slightly aligned so that on a VGA monitor, for example, that's no problem. The pixel ratio is still 1:1, but for modern TVs, the 720 by 480 is 4:5 aspect ratio. So the pixels are for 4:3. Aspect ratio are 8:9. The pixel ratio,
right? And
for widescreen 60:9, image ratio it's 32:27. I think I'm not really sure.
Wow, that's a noticeable difference.
It's meant to be 1:1, the pixel ratio. So any modern TV will either squash the image or stretch it.
Yeah, that's and the thing that makes it even crazier is, at least in my limited testing, maybe only 10 TVs, each one does that differently. So I had a Panasonic Plasma that there was definitely a border around the image that shouldn't have been there, but overall it actually looked kind of good. And on many other TVs, it was all over the place. It was very squished or very stretched or... So it's crazy just to try to get that one signal to display correctly.
Yeah, if you have a computer monitor, for example, you can switch to 1:1 mode. So it's with a big border around the image, but then the pixel aspect ratio is correct.
So with your device, then it will display correctly in 16:9.
Yes,
right?
The 480p, the weird 480p is converted to a real VGA signal.
Cool.
On the digital side, yes, and for that I had to use it's external PLL that allows for it's a bit complicated. The Dreamcast uses 27 megahertz with this 480p signal, which results in 59.94 hertz. It's not 60, it's slightly less. And you need to get to the VGA signal, you need to divide the clock by 1.001, which can't be done in the PLL in the FPGA. So that is done externally to get an accurate clock. for the VGA.
So, are there any side effects of that? Do you see any screen tearing or anything? Like that?
No. It's exactly because the horizontal frequency is exactly the same for 480p and for VGA. So
cool.
It is, and that's also the reason I only need one line of buffer. It's basically buffering 320 pixels and then starts outputting on the on the VGA side, on the HDMI side.
So then, would that mean there's one frame of lag on this if there's a buffer?
No, it's I would say 300 pixels times 27
okay.
megahertz divided by 320 pixels. I think a few microseconds.
Great. So it's not a frame buffer. It's just
no. It's not
okay.
A full frame buffer. It's only one line to get to have a little buffer to get the output.
That's very cool. It's still kind of, even though I've been in this for years now, talking to people, it still blows my mind to think that you could have something do these things within microseconds. You know, it's kind of just a fascinating thing. It's very easy to take for granted too. When you say things like a no lag solution, it's a lot. It takes a lot to get there.
Yeah. For the 1080p output, there is at the beginning of the image if you want to call it a lag, it's 33 lines. Mm-hmm. But at the end of the image, they are on the same line.
Right. That's I think all of the HDMI solutions act like that. I know Kevtris's high def NES, and I believe Marshall's Ultra HDMI is the same thing. But that's not something that could be detected by a human. That's only if you
no.
maybe if you have a very fast slow motion camera. But that's certainly not something that you could tell while playing, even if you're a hardcore fighting champion. Because
and the lag introduced by a monitor or a TV, I think, is much greater than that.
Yeah.
Anyways.
Yeah, I think I often talk about lag, but I think it's sometimes misconstrued in that when I say things like 2 frames of lag, people think, oh, well, it's only 2 frames. But yeah, I was just I was playing a few games with a professional fighting guy the other day, and he was beating me very badly, but I still was having a really hard time because we were just messing around, going through an emulator on a monitor that wasn't a 0 lag monitor. So that 2 frames and 2 frames is now 4 frames, because 2 for the emulation, 2 for that. So to have a solution like the Dreamcast with 0 lag introduced, or 0 perceivable lag introduced at the beginning is a big deal, because you can absolutely notice a few frames without a doubt when you're trying to do these complicated moves, especially when you're playing against somebody way better than you. So you mentioned 1080p. What resolutions will this support?
It's upscaled, it's line doubled to 960p inside the 1080p frame. So you have a border around the image, and it also supports 960p, but this is not supported by all televisions because it's out of spec.
And even if you did run it at 980p, it would stretch it, wouldn't it? It wouldn't be the correct aspect ratio?
The aspect ratio is correct, but a 1080p monitor has to scale it.
Right. So it would either be stretched or scaled.
Yes.
Okay.
Yeah.
I remember messing with that a little bit on using the OSSC, using the 480p line doubling, and I got very mixed results on different monitors. So this is cool. You don't have to worry about that at all. It just sends a 1080p image with the 960 in there.
Yeah, and the pixels are doubled, but they align perfectly with the pixels on the display. So you don't have any blurring introduced by scaling.
Excellent. Yeah. What games did you test in development? Do you have a few favorites that you use to reference?
I try to whole bunch of games. I have a USB GD-ROM and a GDEMU. Also, I tested with both and ran a lot of games.
For me, whenever I'm testing Super Nintendo, it's always Zelda: A Link to the Past. And with Genesis, it's always Sonic 1 and 2, because I know those games so well. If one thing is just a hair off, I could tell, just because that's what I've been using to test since day one. So I always ask if people have go-to games just for things to look for.
I used with Dan. We used some games which have very sharp edges in the video, because we had some interference issues with the audio, and only on those games the problem shows. But okay, now it's solved, but it showed on certain games, such like Ready to Rumble Boxing. It has this start screen with very sharp colored edges, and this we got crosstalk to the I2S lines.
Now, Dan mentioned that last time I talked to him. Did you figure out what was going on with that?
The last thing we had was we thought it was some weird interference, but it wasn't. It was basically because we don't have an on-screen display yet. You have to plug in a cable to set it in VGA mode. And the cable Dan used had a cold solder joint, and it was constantly switching between 480p and 480i, causing very weird issues. And because the FPGA is constantly monitoring the state of the pin and switching between 480p and 480i, the game does this only at start. But the FPGA switches between those two modes and was causing that trouble.
I love stories like this. I can't tell you how many times I've had a problem like that drove me crazy, and it's not fun when it's happening, but after it's fixed, it's always fun to look back. So many funny little things like that. And I was very happy it wasn't a real design problem. It was something like this, something easy to fix, and not real issue in the whole design. Yes. So will you plan on selling any of these boards at all, or is this just more of an open source project?
For me, it's only open source. I myself do not plan on selling this. Dan will do. We work very closely. He brought me back into this project after I did this first prototype. Then I fixed the VGA versus 480p problem, and then I put it on GitHub, I think February 2017, and he posted this, I think, on the Schmaps forum, and then he contacted me a year later, and from then we are working on this very closely together.
Very cool. Yeah, it's there are so many great projects that I've seen get 80% done, and it always seems to stall at the last bit. And sometimes life just gets in the way. You don't have time anymore. Other times, some people are notorious for not finishing projects. I can't tell you how many friends I grew up with that were in bands that had an album almost recorded and then quit at the end. Stuff like that. But it's good to see a project like this come to fruition, because this is, like I said before, this is something people really want. So do you, at this point, is it in a state where anybody could download the information from GitHub and assemble their own, or are there still some last finishing touches to come on it?
I think what's missing at the moment is the FlatFlex connector. Dan has to put it on GitHub. Okay. But and the current board also has the connections for the Maple bus to get the controller integration, and then it's possible to display an OSD. I have also implemented the OSD. We use that for debug information, so it fits barely fits all inside the FPGA RAM. This is the critical point. So at the moment you have to reflash the firmware to switch between 480p, VGA, 960p and 1080p modes. But this can be easily done because we have this ESP 8266 based Wi-Fi update solution.
Yeah, can you talk a little bit about that? Because I think that's awesome and something that I don't even really understand.
Yes, it's this microcontroller with Wi-Fi, very cheap microcontroller. You can buy it for about $2, I think, and it connects to the configuration memory of the FPGA and can flash it from there. And yes.
So is this an ad hoc network that you just connect to it, or
yes? If you set it up the first time, it creates an access point. Then you log into this Wi-Fi network, and then you can configure your own. You can configure it so it connects to your Wi-Fi network at home, and then it can download the firmware directly from a website I set up, where it downloads the firmware and you can flash it.
That is very, very cool. Huh. So at the moment, then it's you don't switch resolutions with the OSD. You switch resolutions over Wi-Fi.
Yes, because we don't have the controller integration finished yet.
Okay. Well, if anybody's good at controller integration, definitely check out that GitHub and see what you could do then. But
yes, I found some very interesting projects on the Maple bus for FPGAs. I will start from there. So the hardware is finished, and if the Maple bus integration is there, you can upgrade the firmware and get OSD support and.
Yeah, so that's the thing. It's funny because when big companies do things like ship a product with broken firmware and tell the consumers to flash it, I always get frustrated. But when hobby projects do that, I'm always excited. Great, get the project out the door. Let's try it out. We'll all help out. We know it's as long as the hardware's set, we can update whatever firmware we need. Yeah. So I enjoy stuff like that.
Yes, because it's totally usable at this time. You just have to connect to the over the Wi-Fi to the website on the ESP and reconfigure it.
So did I miss any features of this? So it's outputs either 480p, line doubled 480p to 960p, but in a 1080p window, or just straight 960p. Is that that's the 3 video modes, correct?
Yes.
And at this time, whatever is outputting over the analog connection will stay. So if it's 240p, 480i, 480p, that's the exact same, and it's just still outputting either of the 3 resolutions on digital.
Yes.
How does it handle 480i games then?
480i is also simple line doubled to 480p.
Okay.
As is 240p. But this will also not work on all TVs, I think, because the refresh rate is a little lower. It's about 58 hertz, I think. It's because the 240p signal has an additional line. It's in the video.
So 240p out of the RGB port would still be 480p or 960p out of the HDMI?
Yes, I did not test it with 960p or the 1080p mode. I'm not at the moment. I'm not really sure if the buffer is large enough, but I assume it is. So if you have the VGA firmware, 240p is line doubled to 480p. And I have also added one-to-one video mode, so you get the 480p out of the system maybe someone likes this. I don't know.
Well, I mean, the one-to-one mode is something that I think is very important for the future. So right now, having 1080p output of this thing is amazing and exactly what we need. But, 10, 15 years from now, when there's 8K TVs, I think it would be much better to have just exact one-to-one digital output and let whatever scale of that time do the multiplication for it.
Yeah.
So, but that is very cool. And it's funny because to me the Dreamcast has many games that would look in 480p look right at home on a flat screen TV. Looks like a modern game that could be released today, but the Dreamcast also has games that look like some of those amazing 90s fighting games. Yeah. So it's one of those that goes straight down the middle, and the fact that you have digital options for all of the resolutions are really helpful, and not just 480p. Because especially the fighting games, you're going to find a lot of people are going to be using this to play on monitors, RGB monitors, but stream through their capture card. So it's pretty exciting. So I think I hit all the features of it: the Wi-Fi, dual output, zero lag. Have you used? I think I heard you talk a little bit about the GC Video project. Now that you've worked on this, and now that you have FPGA experience, were there other things that you were experimenting with?
Yeah, I have some plans. One thing is maybe go to other consoles of this generation. For example, PS2 or the first Xbox.
Oh wow! Is that even possible to do the same type of parasitic pull the digital signals?
Yes, Dan. I talked to Dan about this, and but I didn't do any experimenting yet. It's only an idea, and maybe in the future there will be options.
That's pretty cool.
The PS2 has a video deck, so you can get the signals.
That's very cool. A lot of people disagree with me on this, but I got a backwards compatible PS3 and another PS3 Slim, and I did a lot of experimentation on what it's like to play PS1 and PS2 games through it, because I thought for a lot of people that maybe even have tri-sync monitors, hey, wouldn't it be cool if you just use a PS3? And I was very unhappy with all of the video outputs. In every scenario, it was better to go through either a PS1 or a PS2 and an OSSC in everything that I tried. So I think there's a huge amount of PS2 fans out there that would really love something like this. So that's pretty cool.
Yeah, we see. But we wanted to finish this project first.
Oh, of course, yeah. And some of the work you were looking on at the GC Video as well, was that just kind of poking through the code and seeing, or is that?
Yes. Dan asked me if I can take a look, because there were some issues. I think it's a chroma bug, which Unseen already confirmed that it's existing, and there was this Game Boy adapter software.
The Game Boy interface software. Yeah,
I'm not familiar with the GameCube. Dan sent me one, fully equipped with everything, but I just read through the code and changed the analog output so it works with this Game Boy emulator.
Can you describe a little bit about what you found? Because I found it a little hard to understand, and some of the screenshots that were posted didn't show a very large difference, whereas I'd seen in the past other people just choose different pictures to share that looked, you could definitely see the difference.
Yes, I think the main problem was that the conversion from the YCBCR signal to RGB, there was something wrong. But I haven't figured it out myself, this chroma issue. And in the current firmware, the output, the analog output is derived from the RGB signal generated in the FPGA and not taken directly from the YCBCR signal. even if you use component mode.
Okay, so then it's a translation issue then.
Yes,
Okay.
yes.
That's cool though. It means all the hardware is still perfectly fine. It's just all right. It's always good news.
Yeah.
I see a bunch of tools in your lab behind you. Some of them look familiar to me, and some of them don't. Can you kind of talk a little bit about what you use and what your main tools are? And I'm assuming you had to assemble a lot of these boards yourself, right?
Yes. I have a very nice soldering station. It's a JBC. I don't know if you know. JBC is I think it's a Spanish company, and they have in Europe they sell. They are usually very, very expensive, but in Europe they sell the model. It's about 270 euros. It's cheap for a JVC, but I love this soldering iron. It has very great tips. And then I have a microscope. It's not an AM scope because they are hard to get in Europe. And if you buy one in the US, it's ridiculous shipping costs.
Yeah.
So it's a Bresser. It's the name, Bresser. But it's nice. It has a very, very high working distance.
Oh, good.
You have basically 30 centimeter of space. And it's, yes.
Yeah, after seeing Dan's, I feel like I really want a microscope now.
I need it. I'm a little bit older and I cannot see without a microscope. And it's for me, it's the same as for Dan. I think he's doing everything under the microscope, and it's the same for me. I do even through-hole stuff with a microscope.
Well, if you have the tools, why not use them, right?
Yeah. Yes.
I mean, some of the stuff that you must have to solder for these FPGA kits is tiny, so that would be, I imagine that's a pretty huge help.
Yes.
And I see you have a hot air rework station. I think you have the same one, same knockoff one that I do.
Yeah, very cheap, but it's okay. I do not use it very often. I also solder the TQFP parts with the iron. If you use drag soldering, it's easy to solder, but it's hard to inspect without a microscope.
Yeah, absolutely.
And to align, no? Yes.
Do you have any suggestions or tricks for anybody that maybe things that you've figured out that you could suggest? You know, getting a microscope if you're doing soldering to small areas is certainly something I recommend now after seeing you guys.
Yes.
But
yes, I use a solder. Which is eutectic. I don't know if it's the right term. It's it does not have a range where it becomes liquid. Normal solder is normal 6040 has a range of temperature where it becomes liquid, and the eutectic solder has a specific point where it gets liquid. And I always liked these properties, but I don't know if you really need it.
So when if it doesn't go liquid, what happens? It makes the connection, and then you just wipe off whatever's left.
No, it goes liquid, but it's on point. It's solid, and then when it's on temperature, it's liquid, instantly liquid.
So it's almost like a paste.
Don't get this mushy in between state when you solder with normal solder. You put away the heat, then it gets a little bit mushy before it gets solid again. And this you don't have with this eutectic solder. It's I think. Let me have a look. Yes, it's a mixture of it's 62. Sorry, I don't know how this metal is called in English. It's what the other thing. If it's not lead, it's
the lead-free solder.
No, lead, and the other 6040 is 40 LED
Okay.
and 60.
I'm drawing a blank now.
Okay.
Say it in German. We have a lot of German watchers. All correct.
Thin.
Okay. All right. Yeah, that's a good tip. I want to try that now because I'm always looking for ways that I can get a little bit better. So.
And it has a little silver in it.
Okay.
The eutectic. Yes. But and I use a flux paste. Not because it really works good, but it's hard to get it off, hard to clean.
Yeah,
Yes.
I imagine
So my
with
boards are very messy. I think they're a little bit sticky, but it's okay.
Well, you can get the flux cleaner for that, though, right?
Yes, but
Yeah. As long as
I do
it's
not-
non-conductive, who cares? You know.
yes, and it's no clean. It's okay. And as I'm not doing any installs professionally, or it's only for myself, and I can live with a little bit of residue on the board.
Oh, absolutely. Yeah, that's it's completely different when you're making boards in a lab for yourself than if you're selling hundreds of sticky boards covered in flux. But
Exactly. Yes.
yeah, I got to try that combination then: eutactic solder and then the flux paste, and then see how that works.
And I have a wide variety of tips for the JVC. So I have these. Oh, cannot see. It's basically on an angle and it's very a relatively large area where you put solder, and then you can drag solder with it. Very good.
Oh, cool. Yeah, I'm still using, I have the Ihua, I think is how you pronounce it, the cheap knockoff, and then you have to unscrew this to switch tips, and always end up burning yourself, and it's
Yes. Yeah, the JVC you can you have on the station, you can remove the tip and put a new on without touching it, so you can very often switch between the tips.
Yeah,
Yes.
I need to invest in one of those soon because I'm tired of burning myself, and I'm tired of taking longer to solder something just because I'm using not as good equipment. So, cool. Well, I mean, I think we covered the Dreamcast project. I loved the tips and tricks for some of the hardware and the DE10 Nano kit that you recommended. Was there anything that I forgot? Anything you wanted to mention that I forgot to bring up?
No, I don't think so.
Okay. Well, thank you so much for your donations and your work. Everybody, trust me, everybody is really looking forward to this and is very happy and thankful that you did that. So, any other projects you have in the future, I'm sure people will be willing to help out. And, thanks so much for all this very cool work.
Thank you.
All right. Well, we'll definitely keep in touch because I'm excited to try
Okay.
out this Dreamcast product. All right.
Okay.
Take care, Kristoff.
Thank you.